Exponential, right? It says it up there. Okay. You've copied something similar to this in your notes throughout the year enough times that you ought to be able to get by without doing word for word. Like I said earlier, while some of y'all wasn't listening, the examples is the most helpful part of this. If you get the examples of what they do, you're going to be sitting pretty good. It's always the same. If there's a +7 stuff on the end, it scoops up 7. It's all the same stuff. Where just is a little bit confusing looking since you've got exponential and logs with them now.
At 122. Miss Robinson, please call the middle school office at 122. Thank you.
Alright, we're almost ready for the log one, it looks like. But again, the transformations are the same. I just wanted to do this again because it looks funny when it says log, and that, you know, that plays with people's brains. But it's still the same stuff. So if you can. I know, but I can't.
They should like.
Maybe when they go to school, I don't know.
It's nice that it's just gonna be like.
They're not gonna bulldoze this thing?
We'll still need it.
They don't know what.
That one.
But where are they gonna build a new high school?
Where?
Where?
Where the main building is.
They're tearing down the main
So where's Ben gonna go?
They'll have a new building. Until then, they'll be in the old cafeteria.
Well, they do.
So they won't be able to start the new building until the new cafeteria is done. Because then the band and the choir will go to the old cafeteria.
I don't know how that's working.
Log, I changed it to log. Again, the examples are the important thing. Don't feel like you gotta copy down every single word because you know all this stuff, but the examples are what's gonna help you.
Oh, I didn't write down what the other one was called.
Just exponential instead of logarithmic. So,
Oh, okay.
yeah. I think maybe I'll get to move to a bigger room. Because those rooms over there, the science and the English rooms are bigger. And they're the people that will go to the new building. Maybe I'll always get a bigger room.
No, we'll have.
Get it done, all we're going to do is what we've done with this every unit. Look at some examples of how to move it left 2 or how to stretch it vertically by 7. You know, we'll practice a few of them. We did some the rewriting when we did exponential to log, when we did B to the E N. We watched a video of that.
Okay.
So it was not anything new. No, nothing to make might not hurt you to get the notes from somebody.
So I just like anxious ones, so I just go put those up every time I like it. You have to prescribe and text at least 10 things you would do if you were in one day. Organize lists. I have no idea.
Everybody got it?
Graphics.
Alright, so like I said, all you're going to add to your notes here now is we're just going to work through some like we have with every unit and look at what it'll look like when it's involved in an exponential function or a logarithmic function. Okay? So my marker catches up with me. I was always asleep the first time I turn it on in the morning. There we go. Yep. Let's say I gave you f of x is, this is in your notes, is equal to 1/2 to the x, and then I gave you g of x is equal to 1/2 to the x minus 4. Okay, so all you're asked to do here is to describe the transformation that takes place from f of x to g of x. So this is simple, and I've emphasized this. I know I haven't talked yet because I've been letting you copy, but during when I was getting bored waiting and I would throw something at you, I've emphasized that we've been doing this all year long. So this is stuff we're going to be good at by now. So from F to G, what's changed? Okay, but I mean, even simpler than that. What looks different on the equation?
You added a negative -4.
It's got -4 stuck on the end, right? And then y'all were correct. That means that g of x would have moved down 4 units. And that's it. Oops, I meant to underline and I cut through it. Slash through it. Down 4 units. Okay? So what if we saw, let me throw an e in here now, the number e. F of x, still in exponential, is equal to the number e to the x power. Remember, number e will write with lowercase. Here, can you move that scooter? G of x is equal to e to the x plus 3. All of that in an exponent, and then a plus 2. So we're doing more than one thing on this one now. So just compare from F to G what things has changed.
3 units left.
Okay, very good. This 3 is up there with the x, and so up with the x means left and right, and Garrett remembered it goes opposite way of the sign. So left 3 units, and then say it again, Grant.
2 units up.
Plus 2 stuck on the end would be up 2 units. Okay, pretty simple. Finally starting to catch on a little bit, right? Okay on that? What's the matter? Okay, you kind of made me think you were going to say something. Okay. We got that one? Okay. Let's say we had f of x is equal to e to the negative x, and g of x is equal to negative 1/8 e to the negative x. Okay, now one thing to caution you on here, the f of x's exponent is negative. A lot of people will look right here and immediately say, well, there's a reflection. Well, there's only a reflection if it's the opposite over here. Okay, so don't try to do too much. You're comparing g to f, not g to what we talked about as parent functions. You're comparing it to f. So I would look at this and I would say, keep it simple here, I would say we got an e to the negative x and we got an e to the negative x. So the new stuff is a negative in front of the whole thing and a 1/8 in front of the whole thing. So that's what you're looking for. So what does a negative in front of the whole thing mean? Okay, good, Riley. Negative is always reflection. And what you got to figure out now is it y-axis or x-axis? And it has to do with whether it's in front of the whole thing or whether it's just up with the x. Our negative, I told you, is in front of the whole thing. So that is the x-axis. Very good. Reflection on the x-axis. So we got that negative taken care of. Now we're looking at the 1/8. Anytime we multiply by something, you're thinking shrink and stretch. And so then when it's a shrink or stretch, it can be horizontal or it can be vertical, depending on is it in front of the whole thing or is it just on the x. If this was just on the x, it would have to be up here in the exponent, wouldn't it? But it's in front of the whole thing. So in front of the whole thing, is that horizontal or vertical? Okay, does vertical keep it a 1/8 or does it take the reciprocal? Yes, Tori, it keeps it. Remember, horizontal is the only one that does weird stuff. So vertical will keep it. So since 1/8 is less than 1, makes that a shrink. Very good. Vertical shrink of 1/8. When y'all miss these on a test, it's usually the shrinking and stretching that you miss. Just reason your way through it. See if it's in front of the whole thing or just with the x. If it's in front of the whole thing, you don't flip it. If it's just with the x, you do flip it. Okay, reason your way through those. Let's throw the log at you now. Still doing the same stuff. Start us off with an easy one here. F of x is log of x, just basic log of x. So if I did not write a base, what's the understood base?
10.
10, good, Bradley. We talked about that the day we did the calculator, remember? There's no written base, it's an understood 10. It's called common log.
But the one in the calculator is not like 5.
It's
Say that
10
again?
too. It's 10 too. I mean, the calculator is 10, isn't it?
The one on the front, yeah. But I showed you where to find the secret one, remember?
Oh, yeah. That
You go to A or something?
In the math thing, yep. Okay, f of x is log of x. G of x is log of negative 1/2 x. Alright, so if we're comparing g to f, what's different, both of them are both two things that are different, are right there. And neither one of those are in front of the whole function. Out here where my mouse is, they're only in with the x. And so that makes a big difference. So you got a negative, and Riley reminded you a negative always means reflection. But this negative is only in with the x. It's not in front of the log. So it's over the y-axis. Good. Now we're multiplying, so we're either shrink or stretch. But this 1/2 is not in front of the whole log. It's just in with the x. So if it's just in with the x, is it horizontal or vertical? Horizontal. And horizontal takes the reciprocal. Good, Tori. So the reciprocal of 1/2 is 2. 2 is bigger than 1.
So it's
Horizontal stretch of 2. You got it. Couldn't fit my 2 up there pretty. See, so there's just not anything new. Just I needed you to get some confidence at seeing it with the logs and the e's and stuff in there. Okay, now we'll do a couple where we work backwards, where I describe the transformation and you write the equation. On those, we had the equation and we got the transformation. So, let's say we started here with f of x, this will be an exponential one, is equal to 9 to the x. What we're going to do to that is reflect it on the y-axis and then translate it 3 units to the right. So we got to write what the new equation will be if we take this one, reflect it on the y-axis, and scoot it 3 units to the right. Okay, so first off, reflecting on the y-axis. Reflect means a negative. Y-axis. Is that in front of the whole thing or just with the x?
It's just in with the eggs.
The y is with the x, and the x is going with it.
Okay, so just in with the x. So we're looking like that so far, right?
Yes.
Don't necessarily have to have the parentheses there, but I'm just doing it because I know there's something else to come in a minute, so I'm trying to keep myself straight on that. So we've got that. Check. 3 units to the right. Okay, right and left goes opposite, so I am going to have to subtract 3 from something. Does it subtract it from the end, or does it subtract it from the x? From the x, because remember if it's stuck on the end, that'd be up and down. So it's just going to be with the x. So I really don't like my parentheses I included now, so I'm going to put my minus 3 there. But if I were doing this on a test, I would just write this. Oops, I forgot the 9. 9 to the negative x minus 3. Oh, it's funny now. Let me try. There we go. That's how it would look. Okay. Now, so we had a little bit of debate over the reflection on the y-axis. So look at the table that you copied down for your notes, and wherever you need to make a note on that, reflection on the y-axis, the negative goes with the x. Okay, we had some debate on that, so some of y'all need to adjust to make your notes more clear. Okay, ready to try one more? Give you a doozy. Not really. I mean, you already know how to do it. Okay, got it. Alright, so f of x, this will be a log one, is a funny base, log base 7/9 of x. Alright, so we are going to translate that 6 units up and vertically shrink, so I'm going to put VS, vertically shrink by a factor of 0.5.
So 1/2.
Alright. This one's tricky, so let's stay together. 6 units up, that's easy. What do you do with 6 units up? Very good, very good. So, I'm going to put my plus 6 there. Okay, now we're ready for the vertical shrink. Vertical, so you're figuring out, does vertical go in front of the whole thing or just with the x? Okay, in front of the whole thing. So here's why some people will miss this on a test. When we put that point, and we don't take the reciprocal, because vertical got it right. When we put that 0.5 in front of the whole thing, see how I set that up? What does that tell you need to do now?
Multiply 0.5.
So that 0.5, it's in front of the whole thing. That means it goes to the whole thing. And while I really don't know what this step is, I'll just leave the 0.5 there. But I do know what that step is, right? So we'll say g of x is equal to 0.5 log base 7/9 of x plus 3. That's half of 6, right?
Yeah.
You'd be surprised how many people will not distribute the 0.5 to the 6 on the test. Don't forget that. In front of the whole thing, you've got to multiply it times the whole thing. Now, technically, right here where I put it in the parentheses, that's not a wrong answer, right? Just not simplified all the way. I would take this with that parentheses like that, but what would be way wrong would be You couldn't put it like that. Because if you put it like that, you showed the 0.5 times the first one, but you didn't show it times the last one. That's the difference between the parentheses and not, right?
Yes, ma'am.
Erase that, because that's way wrong. Way wrong. You don't get anything wrong.
Wrong.
You didn't even flinch. He wasn't scared of my threatening eraser. Alright. What do you think on that? Good, good, good. My main objective with you right now, that stuff that we started on Friday with the base exponent number, rewriting into exponential and log, being able to solve those, that's still the main objective. We do have to see these graphs. We see them every unit. We see them on ACT, so that's why we did a little bit review tomorrow. But tomorrow I'm going to give you a review assignment. It's got a little bit of all of it, so you actually get some practice with those logs and exponents. Be able to use the calculator, all that stuff's fine. And that's one thing when we watched the videos yesterday, you did it all without a calculator. Remember on a test on the ACT, you'll be able to hit math and scroll to A like y'all were talking about. You can enter that stuff in the calculator. Okie dokie. You already took.
See, I feel like I do like